This video was made possible by StruSoft. This video gives an overview of a FEM-design grasshopper automation script structure. When the use application.run or live link will also be covered. Here is a grasshopper script that can be used to analyze a steel beam using FEM-design API. It can be divided under 4 headings: constructing model, defining analysis settings, running the analysis, and post-processing the results. Construct model phase is the first step where the model is built. This is where materials and sections are built into elements, supports are defined, and loads and load cases and combinations are created. Next step is to define the analysis settings, what will be calculated and what will be designed, etc. Next step is to run the analysis. Here you have 2 options that will be covered shortly. After the analysis, the results have to be post-processed to turn them into a form that is understandable for humans. Let's dive a little closer to the topics. We will be covering the components more closely in upcoming videos, so this is still just to get an overview of what needs to be done in order to complete the analysis. Here on the left we have the beam in Rhino. Now for the beam component, we have connected the curve, defined its connectivity, defined a material, and defined a section. We have also defined 2 supports. One of them is pinned and one is a sliding support. We have also defined 1 point load, 2 load cases, one that contains the dead load and one that contains the point load, and combine them into one load combination. We also have some load display here for visualization. This way we can visually see the load that is being applied to the beam. The load can be moved by simply clicking on the point that it's connected to and moving it in the Rhino environment. Now to define the settings, for this example we will simply toggle the calculate case and calculate comb to true. Everything else can be on false or default settings. We could also define the design here, but for this example we just want the displacements. Moving on to the next step. Now for running the analysis you have 2 options. You can either use the application.run component, which will open FEM-design, perform the analysis and extract the results. You have to use this when you want to perform an iterative analysis using Galapagos or Wallasey or similar optimization algorithm components. The other option is to use the FEM-design connection component, which will create a live link between the FEM-design software and Rhino Grasshopper. The live link allows you to work in kind of a hybrid mode between Rhino and FEM-design. To run the analysis, we have connected the displacement as the result type that we want to extract, and we will simply toggle the run node input to true. Now after 10.8 seconds the analysis is complete and we have our post-processed results here. I have 3 different load cases / combinations displayed, and I have the displacements for each of them at the element points. They are also color gradiented so that the lighter colors have larger displacements. Now let's turn the live link component on. This will open up FEM-design and build the same model to the model space here. Let's see them side by side. Now we can go to FEM-design and go to analysis and perform the same calculations that we did. We can then see the results to verify that our grasshopper visualization is accurate. Now the result display in FEM-design is very good, but in Grasshopper you can build exactly what you want and need, and it can be anything that you can imagine. FEM-design has a powerful calculation engine, so these tools complement each other very well. Now for the post-processing, we simply extract the load case names with some simple scripts, and then we will build the displacement curves, extract the text values from them and display them on the element points. A color gradient is applied to the text entity.